Thank you so much for watching Elimu TV. This is the only channel that gives you the opportunity to watch and learn. Welcome to our fifth lesson, that is Form 2. We are going to look at the physics topic known as Measurement 1. On Measurement 1, I'll be looking at the following goals in this lesson. 1. We shall be looking at the engineer's calipers. The engineer calipers has just a little description, but we shall majorly focus on objective number 2, which is the vernier calipers. So on measurement 2 is just a development of the topic from a Form 1 topic known as measurement 1. In measurement 1, we used basic instruments to measure length, for example a tape measure and a meter rule. But we came to identify that you can also measure the diameter of a very small object or the diameter of a cylinder or even a sphere. And therefore, we had to determine a suitable instruments for getting the diameter of either the sphere, the cylinder, or a very thin wire. And for us to do that, we came up with 3 instruments which are used to measure these lengths. 1, we have the engineer's calipers, which I don't have. Secondly, I have the vernier calipers at this point. The vernier calipers is used to measure the diameter of a cylinder. So this vernier calipers, we shall be looking at it. It has 2 types of jaws. We have these ones, we call them the inner jaws and the outer jaws. The inner jaws are used to measure the diameter from the inside of a cylinder. The outer jaws are used to measure the diameter from the outside of a cylinder. It also has 2 types of scales, that is the main scale and the vernier scale. So the main scale and the vernier scale, we shall also be looking at it and how this instrument is used to measure the diameter of a cylinder, either from inside or outside. We also have another instrument at this point. This instrument is called a micrometer screw gauge. A micrometer screw gauge is used to measure the diameters of very small objects. For example, the diameter of a wire can be measured using the micrometer screw gauge. The micrometer screw gauge has the ability to measure the diameter of very small objects because it has its value recorded in millimeters. For the vernier calipers, the scale is recorded in centimeters. For the micrometer screw gauge, it has its scale in millimeters. That is why the micrometer screw gauge is used to measure the diameter of very small objects. So I put my micrometer screw gauge aside. Now let us put our focus on the vernier calipers. Before we begin, on your screen, I will show you the diagram showing the vernier calipers. You can be able to see the vernier calipers on your screen. On the vernier calipers, you're seeing the diagram. It has shown you the 2 types of scale. As spoken about, the vernier calipers has 2 different types of jaws. We have the inner jaws and the outer jaws. It has the scale. The scale has been calibrated in centimeters. The vernier calipers itself also has the 2 types of scale. The larger scale you are seeing on the screen has been labeled the main scale. It has been labeled the main scale. That is the larger scale. We also have a very small scale. It is called the vernier scale. It has been labeled the vernier scale. So those are the parts of the vernier calipers and how the scale has been calibrated. So we normally use the vernier calipers to measure the diameter, or we can also determine the radius of a sphere. So if you want to measure the inner radius, then you're going to use the jaws on the top. The jaws on the top are the ones we call the inner jaw. They're inserted inside the cylinder to be measured, and then you pull them and take the reading from the scale. If you want to measure the outer diameter, then you're going to use the lower jaws. The lower jaws have been labeled on your screen. So the lower jaws are going to indicate to you the outer diameter of a cylinder. So on our next the next image you can see on your screen is the image of a micrometer screw gauge. This is a micrometer screw gauge that is used to measure the diameter of very small objects. This includes the diameter of a wire. It has also different types of scale. One, you can see it has the main scale, and it also has what we call the thimble scale or the sleeve scale, in that manner. So those are the two scales that we normally look at when we study the micrometer screw gauge. So each and every reading can only be obtained from the scales that you are seeing on your screen. So number one, I will start by explaining the engineer's calipers. The engineer's calipers, it has also two types of jaw. It has one jaw inside and another jaw outside. The jaws are used to measure the internal and the external diameter, and the reading is then transferred on the meter rule. So these jaws are usually used, either the inner jaws or the outer jaws are used to determine the diameter of a cylinder, and then the reading is transferred to the meter rule, and therefore it can be recorded. So the engineer's calipers are used to take the measurements of cylinders, and on these ones they don't have a scale. The engineer's calipers do not have a scale, and that is why after measuring we transfer the reading to the meter rule, and up to there we can be able to obtain the reading. On the other hand, we have the vernier calipers. So the vernier calipers, as I have illustrated, it consists of two scales. We have the main scale and the vernier scale. So at this point, how do we use the main scale and the vernier scale? So if you have your vernier calipers, number one, you open the jaws. You have the knob on the top. Ensure it is loose before you open the two jaws. You can pull them. Now, after opening the two jaws, place the object to be measured, or place the object whose diameter is to be measured between the outside jaws. So if you have the jaws, you just place the object to be measured between the jaws. After you place the object to be measured between the jaws, record the reading on the main scale. You record the reading on the main scale. That is opposite to the left of the zero mark on the vernier scale. So record the reading on the main scale. After recording the reading on the main scale, go to the third procedure. Read on the vernier scale the mark which coincides exactly with the main scale mark. So on the vernier scale, you have to read that mark which coincides exactly with the vernier scale mark. So after getting where the two coincides, that one will give you what we call the least count. So the value that you obtain on the vernier scale is multiplied by the least count. The least count is 1 over 100, or it can be 0.01. That is on procedure number 3, that after you record, you take the reading on the vernier scale. That value, before you add to that value on the main scale, then you have to multiply it by the least count. This least count is 1 over 100, or 0.01 centimeter. The least count refers to the distance between the two calibrated marks on the scale of a vernier calipers, and this least count is equivalent to 0.01 centimeter. Therefore, the readings in a vernier calipers are only recorded in centimeters. So this reading should be recorded in centimeters, and that is why in an example, at this point, if you are given a vernier calipers in that manner, it has a scale from 0 in that manner, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 in that manner. And maybe you can have another 0. This is now on the sleeve scale in that manner. So this is how you are going to obtain the reading. That at this point you have 0, 0.1, 0.2, 0.3, 0.4. Here you have 0.5, 0.6, 0.7, 0.8, 0.9 in that manner. Then at this point, from 0 you have 0.1, 0.2. So your main scale reading will be 0.2 centimeter. This is up to the point where the 0 mark begins on the sleeve scale. Record the reading on the main scale. Then look at the point where the two scales coincide. The mark on the sleeve scale, which coincides with a point on the main scale, should give you the vernier scale reading. Multiply that value by the least count, so that I have 0, 0.1, 2, 3, 4, 5, 6, 7. So that you have 7 multiplied by 0.01. This value should be in centimeter. So that to obtain the reading at this point, you'll have 0.2 being added to 0.07. At this point, the reading on my vernier calipers here will be 0.27 centimeter. The reading will be 0.27 centimeter. So ensure that you are able to record the main scale reading. Look at the value on the main scale. The value on the main scale can be obtained by counting the values on the scale up to where the 0 mark begins on the vernier scale. That one will give you the main scale reading. The vernier scale reading will be obtained on the vernier scale in where you pick the value that coincides with another value on the main scale. That value is multiplied by the least count, which is 0.01. When you add the value on the main scale plus the value on the vernier scale, this one should give you the total reading in centimeters. So that is how you can be able to record the reading on a vernier scale in centimeters. So when you see the vernier calipers, number one, ensure that when the jaws are placed, the outer jaws are placed on a given diameter, that is of the instrument to be measured, ensure they are tight, they should not be loose, so that you obtain the accurate reading. For example, if this is the diameter to be measured, then you should ensure that these jaws are tight, so that they can be able to hold it very tight, leaving no allowance at that point. They should hold it in that manner, so that you are able to obtain the correct reading. So you just go on the main scale. The main scale, you go there and read that value which matches with the 0 on the sleeve scale. So the value that matches with the 0 on the sleeve scale will give you the main scale reading. On the sleeve scale reading, our sleeve scale is the small scale. Look at the mark which coincides with another mark on the main scale reading. Record that value and multiply it with the least count. The least count at this point is 0.01 or 1/100. That value on the sleeve scale should be added to that on the main scale, so that you are able to obtain your reading in centimeters in that manner. So there are so many questions that usually come on the vernier scale and the vernier calipers. So usually it is very easy. You just take the value of the main scale plus the value on the sleeve scale. Then on the other very important part of this lesson, we have what we call the zero error. So how can you be able to determine the zero error on the vernier calipers? Usually these vernier calipers have what we call the zero error. First, from your mathematics, knowledge, you know what is an error. An error is something that will give you incorrect reading. For example, you can take the measurement from these vernier calipers, and the reading you're going to obtain for that diameter is not correct. Maybe because there is some form of inaccuracy on the scales. Usually it happens in 3 ways. Number one, I've told you that when we talk about the vernier calipers, usually has 2 scales. That is the main scale and the vernier scale. So these 2 scales, we have one on top. The main scale is on top. And then we have the sleeve scale at the bottom. So we have the main scale at the top, and then we have the sleeve scale at the bottom. So these 2 usually begin with a 0 mark. So we have the 0 mark on the main scale, and we also have a 0 mark on the sleeve scale. This is before you take the measurement. Now, my vernier calipers at this point is closed in this manner. This means that the 0 mark on the main scale should coincide with the 0 mark on the sleeve scale. So if they coincide in this manner, in which I've drawn at this point, then this vernier calipers has no 0 error. At this point, this vernier calipers has no 0 error. And therefore, at this point, you can take the reading comfortably, knowing that this vernier calipers has no 0 error. So the 0 error sometimes can be used to determine the reading. So I want to look at the 2 types of error at this point. If we have the main scale at this point and the sleeve scale, we can either have what we call the positive error. How do we describe a positive error? A positive error normally occurs when the 0 mark on the vernier scale comes after the 0 mark on the main scale. So you have the 2 scales. So we have the 0 mark on the vernier scale comes after the 0 mark on the main scale in that manner. So at this point, you obtain what we call the positive error. So when you have the positive error, after taking the reading, you subtract this error on your final reading. Finally, if you have the negative error, which will appear in this manner, so that you have the 0 on the main scale at that point, and the 0 on the sleeve scale at that point, here you obtain the negative error. This point here is positive, this one is now the negative error. On the negative error, you count this value. If at all your scale appear like this before you use the vernier calipers, and then this value is added to the final reading. So that is how errors normally happen. That is the positive error and the negative error when using the vernier calipers. So be very careful that before you use the vernier calipers, look at this, the main scale and the 0 on the vernier scale to ensure that the 2 zeros are coinciding. If they do not coincide, identify whether it is a positive error or it is a negative error. So finally, I'll finish by looking at our little quiz. And our little quiz says that state the reading in the figure shown below. So that is our little quiz. So at that point, make sure that you have that is the vernier calipers, show your main scale and the vernier scale, and then indicate where the two marks are coinciding on the sleeve scale, and then record the value of the main scale, add the 2, and on our next lesson, ensure that you come with the answer. So thank you so much for watching Elimu TV. This is the only channel that gives you the opportunity to watch and learn. Keep on ordering for exams on the numbers shown below on your screen. Thank you so much.